Good day, geographers, and welcome to the coast lesson today. We're going to be looking at depositional landforms, and we're going to get into the nitty-gritty about how beaches and sand dunes form. I had the best job when I was at college, and I used to work at a beach hut, so I used to spend plenty of time on the beach pretending I was working. We're also going to look at some field work and how we can analyse data too. So for today's lesson, you're going to need a pen, paper, and a calculator. In a second, I'm going to ask you to pause the video and go and get them, clear away all those distractions around you, and see if you want to go and work somewhere quieter so you're not going to be disturbed. Right, pause now, get everything you need, and I'll see you soon. Excellent. The title today is Depositional Landforms 1. It's beaches and sand dunes. So if you could get both of those down and underline them for me at the top of your page, we're ready to go. If we're going to look at depositional landforms, it's really important we remind ourselves what deposition is. Deposition is when material being transported by the sea is dropped due to a loss in energy. So if you could pause the video now, I think we should write that one down to help us out through the lesson. Why does deposition occur though? Deposition occurs when the sea loses energy and slows down. It's linked with constructive waves. Constructive because it builds up the beach. Constructive waves are when swash is greater than backwash. There are lots of things that could cause a loss of energy. It could be that the wind dies down. It could be in a sheltered bay. It could be that we enter shallower water. So how do beaches form? Beaches are the area of deposited material between the low tide line to the limit of the storm waves. People think there are just one type of beach, but actually there are many. We get sandy beaches, shingle beaches, pebble beaches, and even coral beaches. And they all look slightly different. Let's look at sandy beaches first. These are normally formed in a sheltered bay. This is due to wave refraction. If you look in the image, you can see that this sandy beach has formed between two headlands. As the waves approach, their energy is concentrated on the headlands. Sandy beaches are formed by low energy constructive waves which transport material to the shore. As the swash is stronger than the backwash, material is moved on to the shore. They have a gentle profile. This means that sandy beaches tend to be quite flat. Beaches that are in more exposed areas tend to be steeper, and they are often pebbly. Higher energy waves remove the sand, leaving the larger shingle behind. Right, let's test what you can remember. Beaches are formed by, nice and quickly, 3, 2, 1. Did you get constructive waves? So we construct the beach, so therefore constructive waves. It is most sheltered where? In a bay or on headlands? Jot it down. It is most sheltered in a bay. This is because the wave's energy focuses on the headlands either side. Which one of these is not true about sandy beaches? You need a little time to do this, so pause if you want to. Have you written it down yet? So the one that is incorrect is steep profile. Sandy beaches tend to have flat profiles or gentle profiles. Let's move on now and have a look at sand dunes. Sand dunes are small ridges or hills of sand found at the top of a beach, away from the reach of the waves. They need certain conditions to form. There needs to be a large supply of sand because that sand is needed to pile up to create the dunes. There needs to be a large flat beach so there's room for the dunes to form. We need an onshore wind to blow the sand, and there needs to be an obstacle for the dune to form against, for example, seaweed or driftwood. How do sand dunes form? Wind transports sand along the beach through saltation. Saltation, and jot this down for me, is the bouncing of particles along the beach by the wind. When I was sat on the beach the last time I went, we were having fish and chips, and it was so windy and the sand was blowing and really stinging my face where it was being blown along. That's called saltation. Deposition occurs around obstacles such as rocks or seaweed. So you can see in the image there's a piece of seaweed, and that sand that's been transported through saltation gets stuck on it and it starts to build up. Over time, the sand builds up, creating small embryo dunes. So the first sand dunes that are created are embryo dunes. These dunes are stabilised by vegetation such as marram grass. The long roots bind the sand together. So if you look at the image, we get marram grass and lime grass, and those roots dig deep into the sand, holding it together. This stops it from blowing away. They then develop into foredunes and yellow dunes. Over time, the rotting vegetation adds organic matter to the soil, and so more vegetation is able to grow. As you move further back through those sand dunes, you get more and more types of vegetation. Eventually, smaller dunes will form in front and the process will start again. This is a cross-section of a sand dune. You can see the sea on the right-hand side. You have the area of beach in the foreshore. Then at the back of the shore, so the back shore, you would start to get your embryo dunes building up. It goes embryo dune, foredune, yellow dune, grey dune. The vegetation as you move away from the sea increases. This is because vegetation colonises. Right, let's test. Which is not true about the formation of sand dunes? You're going to need to pause the video so you can read all of these because they're quite long. Right, let's see if you got it right. It is B. So vegetation on sand dunes decreases as you get closer to the sea. So on those first dunes, you would just get one or two species, normally marram grass and lime grass. As you move further away from the sea, you would start to see heathers and lots of other species appear. Big task. You've got boxes on the screen to show you how a sand dune forms, but they are not in the correct order. So I would like you to pause the video and write these statements out into the correct order. Make sure you press play and join me to check you're right. Good luck. Let's see how you got on. Number 1. Wind transports sand across the beach through saltation. Saltation is the bouncing of particles. Deposition occurs around obstacles such as rocks or seaweed. Over time, the sand builds up, creating small embryo dunes. These dunes are stabilised by vegetation such as marram grass. The long roots bind the sand together, creating foredunes. More dunes form in front. We're lucky in geography that we're able to do field work, but when we look at that fieldwork data, we need to be able to put our math skills to the test to help us analyse it. Let's have a look at an example. You can do lots of different fieldwork activities on a beach, and in the photo you can see a girl having a look at the type of rocks. She's looking at pebble size. So in some areas of the beach, like the foreground of the photo, we can see very large rocks. However, as you get closer to the sea, those rocks become more rounded and smaller in size. So the main type of fieldwork we can do on a beach is we can think about how pebble size changes. And in that photo, you can see some calipers. Those calipers are used to accurately measure the size of the pebble. And we always measure the longest axis, so where the pebble is longest. Or you could have a look at how the pebble roundness changes. We would categorise rocks from being very angular all the way down to being well-rounded. And the more the sea erodes these rocks, the more and more rounded they become. Let's have a look at some pebble size data. A student went down and measured 9 pebbles at just one location on a beach. So she took 9 samples and she measured their size in centimetres. The first question I want you to consider is, why do it 9 times? If you're in the same place, why not just pick up one stone? Have a quick think. What are your ideas? So we always collect more than one sample. If I only picked up one rock and it was sample number 9 and it was 20 centimetres, I would think that the pebble size is really large. But the reality, when we look at more than one set of data, is that lots of those pebbles are significantly smaller. The pebble that was 20 centimetres is a bit of an anomaly. It outlies from the rest of the data. So by increasing your sample size, you make your data more reliable. So this is about reliability. To increase reliability, to make sure that that data is repeatable, you have to increase the sample size. Another word geographers use is accuracy. How could we make this data more accurate? And this is making sure the measurement is correct down to the nearest millimetre. They've measured the pebble size down to centimetres. You could be much more accurate than that. You could measure it down as 11.5 centimetres. So you could increase the accuracy by adding millimetres. How would we show this data though? We've got 9 sample sizes. How are we going to put it on a graph? Sometimes in geography we use a dispersion graph. These show frequency of data. Each dot or cross represents one data set. Let's have a look at that data table again. Up the y-axis we have the size of the pebble, and along the x-axis we will show frequency. So sample number 1 is 13 centimetres. That would be plotted on the graph here. Sample number 2 is 4 centimetres. Sample number 3 is 5 centimetres. But then we've got a repeat. So sample number 4 is 4 centimetres again. So here we just put the cross further along. It's almost like a tally chart. Sample number 5 is 4 centimetres again. So we just go over another cross. Sample 6 is 9. Sample 7 is 11 centimetres. Where would sample 8 go? I want you to point to the screen for me now. Sample 8, 11 centimetres. Touch the screen, show me where. Yes. Up there, it's the second time we've seen number 11, so it stands by the side. Let's check you've really got it. So where should sample 9 be plotted? 3 options, A, B, or C. Write down the letter when you've decided. Okay, tell me what you've got. Have you got C? We've collected data, we've looked at how it's graphed, but we always need to analyse it and manipulate it. So I would like you, before we start, to pause the video and copy these key terms down, please. Let's have a go at the range first of all. So the range of this data is, remember we've just written down that the range of data is the largest number minus the smallest number, 5 seconds. Okay, largest. What was the largest number? Tell me. 20. The smallest number? 4. 20 minus 4 is 16. Well done. Then we've got the interquartile range, and this gets a little bit trickier. So the interquartile range is the difference between the upper and the lower quartile. It's the range between the two quartiles. First thing you need to do is you need to put your data in order. Here we go. So we've got 4, 4, 4, 5, 9, 11 and 13. The median is always the middle number. So the middle number here, I've got 7 numbers in total. So the middle number is 5. The lower quartile is a quarter of the way through this data. So if 5 is halfway, a quarter of the way through is 4. The upper quartile is then 3/4 of the way through. So that is, can you tell me? 11. Good spot, well done. So we know what our upper quartile and our lower quartile is. We want the difference between the upper and the lower quartile. So 11 minus 4 is, yes, 7. The interquartile range is 7. So it looks tricky, but all you have to do is put the numbers in order and work it out. You can draw all over the numbers, cross them out, circle them. Number 1, suggest one way to make the data collection technique more reliable. 2, you're looking for the mode. 3, the range, and I've changed the data set, so no cheating. And 4, calculate the interquartile range. It's going to take you some time to do this. Go slowly, look at those definitions we've written down, use your calculator. Pause the video now, and good luck, everyone. How did we get on? Number 1, to make something more reliable, we need to increase the sample size. Hopefully you got a big tick there. The mode is 5. We can see that 5 has appeared twice. No other number has appeared twice. The range is 14. 16 was the largest, 2 was the smallest, giving us a range of 14. And then that tricky one, interquartile range. So the first thing we do is put the numbers in order. Ta-da! Then we're looking for the lower quartile. We are looking for the upper quartile. And we are doing the upper quartile minus the lower quartile. And that gives us 7. That is super tricky to get those maths skills right, okay? But you've just got to follow the recipe. You do it in maths lessons, it's just the same in geography lessons. Well, that brings us to the end of today's lesson. We've learned about depositional landforms, including beaches and sand dunes. We've learned that sandy beaches tend to have a gentle profile and pebbly beaches have a much steeper profile. We've also looked at a range of maths skills. You know what I mean. But don't zone out of geography mode just yet. It's quiz time and I want you all performing in the upper quartile. So click to the next page. Make sure you complete the quiz. Thank you so much for your time today. Take care, and I look forward to you joining me soon as we start to look at more depositional landforms. We're going to be looking at bars and spits. Have a great day, everyone.